The last thing we're going to look at in this particular topic is the primitive function. Okay. Now, with our calculus, we've been starting with an equation of a curve and finding the slope of a tangent and then the equation of the tangent. So the question then comes is, what if we've got the opposite question? What if we know the equation of the tangent, we just don't know the equation of the original curve? So we've got to go back the other way. So we're going back to the starting point, hence the name primitive function. Primitive means going back to the start. It's all right. We know that when we differentiate, and we're just talking about a polynomial here, but we know that when we differentiate a polynomial, we subtract one from the power. So logically, to go back, we should add one to the power. So that's the first thing. X goes to the power of n plus 1. Now, when we differentiated, we multiplied by the original power. So now we're going to divide, but we don't divide by the original power, but the new power. The reason we have to do that is because imagine this was the original function. Function x is x to the n plus 1 over n plus 1. If I said differentiate this, we have to get to the answer x to the power of n. So when we differentiate x to the n plus 1, we would bring the n plus 1 down. That now cancels with the n plus 1, and we get our x to the n as required. But there's this extra thing, plus a c, plus some constant value. Because that's the thing. When we differentiate a constant, we know we get 0. So when you integrate nothing, logically you're going to end up with something. We just don't know what it is. Okay? So we always put this plus a c in because there might be some constant value there. And unless they give us more information, like a point that's on the original curve, we can't actually work out what that constant is. It's okay. Our derivative is 3x to the 4. What did it come from? So basically it's add 1 to the power over the power. So 3x to the power of 5 over 5 plus a constant. And just like differentiation, if we've got several terms, we just do it one at a time. So each one of these, we'll add 1 to the power over the power. So x cubed becomes 6x to the 4 over 4. Then the 5x squared, 5x cubed over 3. X, which is of course x to the power of 1, becomes x squared over 2. And the constant 2, well, that's really 2x to the power of 0. So add 1 to the power of the power, we get 2x plus some constant. Now, that first term, of course, tidies up. So we have 3 over 2x to the 4 there. So here's one where we can work out the constant, because they've told us the original curve does go through the point 1, 1. And it has a gradient function. Well, a gradient function is just a fancy way of saying the derivative. Because remember, the derivative is the function that allows us to find the gradient. So we know the derivative is 2x plus 3. So find the primitive, add 1 to the power over the power. 2x will go to x squared. 3 will go to 3x plus some constant. But in this case, we can work out our constant because we know that when x equals 1, y equals 1. Substitute that in. Constant turns out to be negative 3. So the original curve that we started with must have been x squared plus 3x minus 3. Okay, so 10J.